Hello class, let's take a look at example 3, and this is what they're asking for. They want us to do a confidence interval for the actual with the mean, and we're given the following information. So in this scenario, we are not given sigma. So sigma is not given. Automatically this is going to be a t interval. Now the best method to approach this problem is, well, enter the data set into the calculator. So let me clear all of this and I'll wait for you guys. Take a minute. I need you to enter the entire data set and then please verify if we're matching on the following calculations. So what we're gonna need is for us to run a one variable stats. So remember, you go to stats, then you go to calculate and then evaluate. So let me just go to number, so calculate, see if you're matching. In this case, we're looking at n being the values of 8. Next value that we need is the mean. So x bar is equal to 140.5. And then the standard deviation of the sample, I'm going to pick 4 decimal places, 16.2481. So 16.2481. And we're rounding to a total of 2 decimal places. Now, the next evaluation that we need to do is the critical value. And in this case, they're not asking for the critical value, but let me still do one example where we actually show it. So this is going to be the sketch of the critical value. Now, your critical value, it's not going to be the one, any one of these from the chart, because technically this is if sigma is given. And if it's not given, then you're looking at this specific scenario. So for this problem, in order to actually get the critical value, you're looking at, well, the critical value comes from a bell-shaped distribution. And I'm just going to go to the value. This is going to be a T1 and this is going to be a T2. You're looking at, well, these technically shaded regions. And then the information that we're given is that this is 0.99. So if C is equal to 0.99, alpha is equal to 0.01, or alpha divided by 2 is equal to 0.005. So each of these tails contains 0.005 in terms of area. Now, your degrees of freedom are equal to n minus 1. In this case, 8 minus 1, or a total of 7 for the degrees of freedom. So to find this critical value, you're looking at 7 degrees of freedom, area in one tail to be 0.005. So to identify this one, you're locating the t-table. And in this case, 7 degrees of freedom and one tail 0.005 happens to be 3.499. So this value here is 3.499. So the CV, it's going to be approximately 3.499. Now the standard error, or E, and let me just go back to the formula. It's going to be the following formula, but with an actual standard deviation of the sample and the t-value. So the standard error happens to be, in this case, this is going to be the t-value of alpha times the values of s and over the square root of n. So in this case, 3.499 times the standard deviation, which is 16.2481 over the square root of 8. And please evaluate. This is going to be approximately 20.999. 10.03. That's going to be our actual standard error. I'm just going to select 2 decimal places. So 20.10. Now, the CI will be evaluated by the following formula. So technically, mu plus or minus the values of x bar plus the standard error. And in this case, wait, this formula is wrong. Sorry, you guys. So this is mu less than x bar plus the e. And then x bar minus the e. And in this case, mu, it's going to be bounded by the following 2 values. So we're looking at, well, in this case, x bar plus or minus the e is equal to, and our x bar was 140.5 plus or minus 20.10. Please verify if you're matching. My upper bound is 160.6 and my lower bound is 120.4. So remember that all actual CIs have to have a disclaimer. So you simply have to say that this is a 99. Therefore, I'm just going to say that the 99 confidence interval for mu happens to be between 120.4 to 160.6. And the actual unit is blood pressure. So this ends up being our final answer. In this particular problem, they're not asking for the critical value. They're just asking for the confidence interval, which is the estimate of the mean. And let me show you how to actually calculate this using just the software. Most of the problems are just going to want the software, but I wanted to give you another example. So you're going to go to stats, and then you're going to go all the way to test. And in test, you're going to go to number 8. Now, the data that you have is actually data. So you inputted already the data, and then you go all the way to the bottom and just modify the actual sea level. This is a sea level of 99. Please run it and see if you're matching. In this case, we're right on the dot. We're getting 120.4 to 160.6.